This paper talks about CyberScore, that is a novel concept we have developed for detecting cybersecurity-oriented threats. Most cybersecurity tools that we have used and we have evaluated have poor network visibility, as they mostly focus on cybersecurity. So this means they are very good for detecting cybersecurity threats, but have almost no idea of what is happening at the network level. And also, many of them are using signatures or rules, where for rule we say and we expect to see something like if this and this and this happen, then, that are very specific, that are very good for detecting known threats and known issues, but are not very effective, in particular if you want to detect zero-day attacks. Also, we have in our mind the idea that our tool should not have prior knowledge, so it should not require some sort of training or complex setup in a network by the network administrator, simply because network administrators are people that know their network, know their data, but they're not programmers or nor they are experts and have very advanced programming skills. So therefore, we believe that tools that are based on signatures, such as those based on the popular open source Suricate DS, are good to emit signals that are used by other type of tools, such as those based on artificial intelligence. But the problem relies on the fact that those tools are only designed for cybersecurity. Instead, in general, we need to understand what is happening at a network level, not just in terms of cybersecurity, but also in terms of network communication in general. So therefore, we want to develop, and this was our motivation, something that is simple to operate. We like artificial intelligence, but we believe that the tools that we have evaluated, in particular some commercial tools, are very complex, okay, and require many times the vendor supervision. That is not something we expect from a tool. So therefore, we would like to limit the operational cost using commodity hardware, and therefore we believe that we want to have a system that is not based on signature, because we want to be able to see what is happening on our network, and even though we have no clear knowledge of the problem, at least the tool it is able, in case of a zero-day attack, to report or to drive the network analyst towards the problem. This is very important for us because, as I said, we don't want to push people to continuously update the system or to buy daily signatures that have to be installed on a running environment. Therefore, we have based our work on statistical methods that we believe are very effective, are very robust, since they are available since many years. And therefore, we have decided to release our work as open source because we want to be used as a starting point for a deposit, and for people who want to use our tools to start their work. What is the CyberScore? This is the key concept that we introduce in this paper. It's in essence a relevance indicator that we assign to every observed network activity. It is a numerical value. 0 means no threat, no risk with this communication, and the value increases with the severity of the problem that we have reported. So, for instance, there are very minor issues such as retransmissions, to a very important, very major, issues such as when somebody is moving a binary application, or when we observe a SQL injection in a clear text communication. So, based on the threat that we have identified, we generate a numerical value. This numerical value it is used to feed other type of components, because from the flow level, okay, we generate this CyberScore that is used to increase the client and the server, host, network, and autonomous system, and of course the monitoring interface. So in essence, we split the CyberScore to the client and the server according to the severity and to the type of problem detected. So for instance, when somebody is sending a cross-site scripting request to a server, the server is the victim and the client is the attacker. So therefore, we put most of the CyberScore value into the client and very little on the server, even though the server can have a non-zero value simply because it's under attack. Similar to multivariate time series analysis, the CyberScore is therefore able to condensate into a single numerical value many sources of information generated by something we call checks, and I'm going to talk in a second, that are coming monitoring different aspects of the traffic. In essence, based on the network traffic, we generate through an open source deep packet inspection library called NDPI something we have called flow risk. And every flow risk comes with a metadata. So, for instance, if you have an invalid flow simply because this flow reports a clear text credential, we report into the metadata, for instance, the username that has generated that metadata. And this value is reported also to host, to network interface, to autonomous system, and it is used also to feed other type of data. So, for instance, the network. So therefore, we know not only that a certain host is compromised or is creating trouble, but also that a certain network that contains such a host has trouble. And in essence, at the end of this picture, we trigger alerts based on threshold. So when the CyberScore is going very, very high, or if the CyberScore is changing in behavior. So for instance, there is a spike or a relevant change in behavior. How do we do that? We base this on something we have called checks. Okay, as I said, at the network level, the checks are based on the network traffic. So for instance, when we have data exfiltration, so when we see that in ICMP or DNS traffic, we see something that looks like a data exfiltration such as a VPN. So this is a typical example. Or another example when we have suspicious traffic. So for instance, in HTTP, we see the user agent that is unexpected, that contains some unexpected characters, or looks like some PHP code, for instance. Or when we have obsolete version of certain protocols. So for instance, old version of TLS, of SSH. Other example, when we have a possible exploit. So when we are able to detect in the traffic, clear text traffic, specific characters or specific code that looks like an exploit. This on clear text, but we also have other indicators or other checks for encrypted traffic. So for instance, we're able to identify encrypted traffic analysis, so identify, let's say, DGAs inside TLS traffic, or we are able to also understand if certain TLS traffic looks like hypertext or looks like a traffic that is not used for hypertext transfer, so therefore can be a VPN and so on. These are typical examples of checks. In addition to those, we have something we have called host checks that are, for instance, based on thresholds. So whenever a host is contacting too many network time protocol servers, so this can be something suspicious. So per se, the flow is okay, so NTP traffic, no problem. The problem is that the host is talking with too many NTP servers. Other type of example are scan detection, network port scan, or when we have behavioral alerts, so when a host is talking with unexpected number of clients or servers with respect to its recent past. Another example is lateral movement. So when a host is talking with too many different services or with services that were not contacted before. So this is also leveraging on something we call service map that contains, it's a graph that contains an indication of service that we expect to see in the network, or a behavioral map where we see, for instance, the frequency of communications between hosts when they increase or if they are running at a very low pace. This is also something unexpected. These are based on host check. So we have other type of check that I cannot describe for the sake of time, but they should give you an idea that we check not only the traffic at the flow level, okay, as IDSs do, but we also do something on top of this that allows us to understand whether something is happening at a higher level, at, for instance, a host level. And of course, CyberScore is a good concept, but it needs to rely on signals that are reliable. This means that we need to have no false positives. A false positive doesn't mean that our software is detecting something that should not be detected as such, but it means that sometimes we are detecting real issues on traffic that are not relevant. Let's make an example. So if you have an old badge reader, okay, that you use in your company and that you cannot replace, and if you have secured this badge reader in a way that is not creating any trouble, but because it's doing a certain activity and only that, then we have to silence those communications, simply because the risk reported by the badge reader is something that we are aware that as issues, but we are also aware that this resource has been protected. So therefore, we have a phase called triage, where we have to silence those things that are not nice but are not important. So this is the only thing that we require at the beginning to after you have deployed our system. We have done an extensive validation on two different scenarios, on a service provider level and on a corporate network. The service provider is important because it's a totally open network, similar to the one you will find in many universities, where you have about 2,500 hosts that are delivering data to remote users. And instead, in the corporate network, we have protection implemented with the latest modern firewall IDS and EDR systems that should not have any nasty traffic. Okay? In this second network, we have, because the company allows us to do this test, AI-based tool that is one of the market leaders. So at the end, we have compared our results, the issues that we have reported, with those reported by that tool. Instead, in the service provider, as I said, we have almost no protection, and we have constant communication from everywhere in the world to those hosts. So they're two very different environments. For the validation, we have used commodity hardware, and we have used NDPI, the DPI toolkit I used in detecting flow issues, and TopNG, that is a web-based monitoring application that is sitting on top of that, and that is also sending to an open source database historical flows for later analysis. What are the lessons learned? As I said, you can read the paper for an extensive description of the CyberScore and how we have designed that. I just want to report you what we have learned using CyberScore for a few months in a real environment. So first of all, the triage phase, as I said, it is very important. So it must be, performed at the very beginning, because it allows us to have clean data and clean signal. Behavioral alerts based on exponential smoothing techniques help us a lot to understand and to report the situations that were not easy to detect by a human. For instance, when you have a suddenly change in terms of hosts that have been contacted or that contact certain hosts, this is a typical example. And also, we have seen that, especially with the service provider, high-quality IP reputation blacklists are very, very important, because out of 4 alerts, 3 were triggered by those hosts listed in those blacklists. So they are very good. They have not reported any false positive, but they must come from high-quality sources. Okay, it's very important that. For attacker detections, it would be nice to partition the host that we are monitoring into pools of hosts that are homogeneous. So for instance, a Windows server, VPN servers, or other type of servers. This is because you can tune the CyberScore according to those hosts. So while this step is not very important, it definitely can help to simplify the understanding of the alerts, simply because you can replicate a certain check to similar hosts. Let's make an example. If you have a router, you don't expect the router to be contacted through a protocol such as a remote desktop. Okay, so this rule is general, but if you can apply it in a certain pool, you can increase the CyberScore in a way so that it can be even more relevant for this type of resources. But again, this is not so important, it's just nice to have. The triplet and twin counters, so for instance, IP source, IP destination, and destination port, if observed at the minute level in terms of absolute behavioral value, are very important for us to detect the scanners, even those that are very smart, that they try to hide themselves. And in particular, for slow scanners, instead, we have used different techniques that allows us, for instance, to supervise the connection frequency and the flow size analysis that usually have a very high variance in normal traffic, but are very low variance or zero variance in case of a scanner. So this has been very effective. Also, we have seen that DNS traffic is very important, in particular for DGA analysis. DGA is not only implemented in DNS, but also on TLS and QUIC. But just to say that DGAs are important today, not just as a source of trouble, unless you have an unknown protocol talking to a host previously resolved as DJ, but also because they are used to detect IP reputation by many different servers. Also, we believe that signature and behavioral-based algorithms are ineffective for zero-day attacks. That is why we believe that it is necessary to have some sort of service map. So create a model of our network and to see, and this is one of the future directions that we want to take, allows us to understand how the network is behaving and how the network is changing. And whenever we see a popularity change in something, IP, domain, service usage, we believe that there is something special happening. And this has to be implemented per host. That's why we need a very lightweighted model, and the models have to be created by the tool itself and not by a network developer. So just to complete, this paper has implemented the concept of CyberScore. It is described throughout the paper. So we have compared our results in real networks with tools coming from AI market leaders, and we believe they are very similar. We see, we think, an advantage in our tool because we are focusing not just on cybersecurity, but also on network in general. So therefore, this is a plus for network administrators. And also, we have demonstrated that our tool, as open source tool, is mature enough to be deployed on a commodity hardware and to be able to monitor gigabit network with no problem whatsoever. Thank you very much for listening to this presentation. In case you want to download our software, this is the URL link.